Hello children, welcome back to EDUHUNT classes where you can excel in academics. In the previous video clip, we solved regarding worksheet 5 bits, right? Now here we are going to solve the mains model regarding worksheet 5a bits. Okay, ready? Are you ready? Yes, here we go with the starting question. Question number 1. HCl gas cannot act as an acid in dash. The options are polar solvents, highly polar solvents, NH3 liquid, non-polar solvents. HCl gas is given. No. Wait one second, children. Okay, fine. So tell me. Hydrochloric acid. Hydrochloric acid gas cannot act as an acid in what? This concept we did in the Arrhenius theory concept. You know, I told you there where HCl can't act as an acid when reacted with benzene, C6H6. Did you remember that concept, children? So what is C6H6? It is a polar solvent? No, then what is that? It is a, yes, non-polar solvent. So HCl cannot act as an acid in the non-polar solvent. Okay, that is the question regarding the particular one. The option is D. The option is D. Very good. Now, next question. Children, it can act as acid in polar solvents, highly polar solvent, because why? It gives rise to the H plus ions also, and NH3 it is a base. It happily reacts with acid plus base. HCl is an acid plus base gives rise to salt and water. Okay. Okay. If HCl plus NH3 are reacting, it gives rise to NH4 plus Cl minus. So it is a reacting as an acid in the NH3 liquid, but not in the non-polar solvents. Okay. Now next bit, question number 2. Arrhenius neutralization involves. Okay. Did you remember neutralization reaction regarding the Arrhenius concept? Did you? Okay. So here we have the options for formation of a dative bond. No. Formation of water by combination of H plus and OH minus. Yes. We observed this water combination of H plus and OH minus. What is that water named as? Undissociated water. Very good. Undissociated water is formed when H plus ions and OH minus ions are reacted and added up to give H2O. Do you remember that, children? Yes, H plus OH minus giving rise to H2O, which is the undissociated water. Okay. So transfer of proton, formation of H2O plus is not there. So option B for question number 2 is right option. Okay, formation of water by the combination of H plus and OH minus ions. Okay. Question number 3. Yeah. There is equation X plus Y gives rise to S1 plus H2O plus Q1. Children, X is a strong acid, it seems, Y is a strong base, and S1 is salt, H2O is water generally, and Q1 is the amount of heat liberated. Okay, Q is the amount of heat, liberated. Okay, so in the first case Q1, they are asking us to find out the values of Q1 and Q2. So in the first equation we have strong gas and strong base to give rise to salt plus water. Children, you know what? In the previous worksheet 4 or 4A, I don't know exactly. In that I told you when a strong base and a strong acid reacts, it gives some amount of energy liberated. The value of the number, the amount of heat liberated with some value, kilocalories per mole I told you. Did you remember? I told you in kilojoules per mole also. I told you, children, in the page number, yes, 22, question number 7. Question number 7, if you observe that worksheet 4, question number 7, page number 22, if you see, I told you there. What is that? Okay, whenever a strong gas and strong base react, they liberate with some amount of heat, and that is having the value minus 13.7 kilocalories per mole or minus 57.3 kilojoules per mole. Did you remember, children? Yes. So accordingly, what is the given option? Yes, it should have the amount of heat will be equals to, very good, it should have minus 13.7 kilocalories per mole, and is given here, it is equals to, the minus is children, minus in the sense the heat is liberated, no, that's the value. Minus means like that, because delta H will be there. Delta H is negative, means the heat is liberated outside. Heat is liberated outside. In the sense we can feel the warmness for the reaction in the particular beaker. Okay, if you touch the beaker, it will be warm. Okay, so here it is minus 13.7 kilocalories, and for weak bases, reacting with weak acid, it gives salt and H2O plus Q2. No, Q2 is having the value less with that of minus 13.7. You know why? Here in Q2, we can say Q2 is having the reaction between weak acid and weak base. Here, in that condition, some energy is utilized, which means it is used to ionize weak species, in the sense weak acids and weak base. So in that condition, it is not exactly minus 13.7, it is having the value less than that of minus 13.7. So it is, it is less than that of minus 13.7. Okay, the option D is correct, because it is having Q1 and Q2 values matched with that of given options. Okay, clear? So here, when strong gas and strong base reacts, it gives approximately equals to minus 7.7 kilocalories per mole, and if weak gas and weak base reacts, it gives less than that of minus 13.7. Nearly it may be 13.3, 13.4 like that. You know why? Because some energy is used or utilized during the equation reaction, because it is ionizing into weak acid, weak bases, weak ionized into salt and water. No, in that case we have to say that it is having less the value of minus 13.7 kilocalories per mole. Okay, clear that? Okay, so third question is having the option D. Clear? Now next, question number 4. Here they gave the examples. Okay, children, see, NaOH is a strong, NaOH is named as sodium hydroxide, it is a strong base, SB I'm writing over here. Okay, and HCl, it is a hydrochloric acid or hydrogen chloride, it is having strong acidic nature, SA. It gives rise to salt and water plus X kilocalorie per mole. Now guess what is X? Because it is strong base upon strong acid reacting, what is it? X will be the Q, the charge amount will be minus 13.7. Okay, yeah, here we have okay, A and C are options matching with that of strong base and strong acid, first equation. And second equation, we have acetic acid, CH3COOH, it is a weak acid, and NaOH, it is a strong base, and it gives salt and water respectively white calorie. We know if it is any weak, we have to remember that it should be a less than that of minus 13.7 kilocalories per mole. Okay, where it is? Okay, here the option C is correct. You know why? Because it is having matching with that, because strong base, strong acid, 13.7. Children, minus is nothing but the liberation of heat outside, but not the value, negative value. Okay, thus liberation of heat outside. Okay, so 13.7 minus 13.6 is the right option, and here it is less than that of minus 13.7. Okay, these equations of X and Y are these. Option C is matched. Okay, clear now, children? Okay, question number 5, last question for you. Okay, modified Arrhenius theory is applicable to. Modified Arrhenius theory is applicable to. See, normally Arrhenius theory is applicable to only aqueous solution, right? Dissolving in aqueous and giving rise to H plus ions and OH minus ions respectively, hydrogen ions and hydroxyl ions respectively. But modifications further into Arrhenius theory came that it is applicable to both aqueous solutions and non-aqueous solutions as well. So option both is true. Okay, clear? Did you understand the question number 5? Yes. So these are all the 5 bits regarding worksheet 5A. Hence, here we end the chapter 1, that is acids, bases and salts, regarding the last topic, Arrhenius theory of acids, bases, and the concepts of worksheet 5 and worksheet 5A. Okay, hope you really enjoyed, thoroughly got the concept of acid, base and salts, and looking forward for you to solve many more bits like this for clear identification and the progress in the chapter acid, bases and salts. Okay, here ends the session. Thank you.